All right. So which one again, sorry?
28.
All right. This one here, right? Now, this is in the quadratic formula section, so if you're not able to factor it, you should use quadratic formula, since we're in that section, just to get used to it. Are you sure you can't factor this? What's special about 36 and 49? What's special about that?
They're both roots.
They're both
Square roots.
squares, so they could be square rootable. I like it. So I'm going to try. If it doesn't work, then I'll have to do quadratic, and quadratic would so desperately suck, right? Look at 36, 84, 40. It's huge, but we've got calculators, right? No big deal. Well, let me see if this works. 36 is 6x and 6x for 36x squared. 49 would be 7 and 7. Now, you don't just stop there. You don't just say that's right. You got to check. I know that's good because I made it. I know that's good because I made it. I got to check to see if that's good. If that ain't good, then I'm shit out of luck. And I got to go back and do quadratic. Is that good? What do you get for the middle term?
42.
42, and 42 is, so it worked. So if this would have been an 81, I would have 42, 42, erase, quadratic, oh shit. Right? But quadratic should be a second resort, maybe. I mean, not a last resort necessarily, but I could factor that. So then, how do I finish this out?
You move the 7.
Yeah, well, after doing what?
Plus 7 squared.
So I say that 6x plus 7, but you can look at it two different ways. 6x plus 7 equals 0, or 6x plus 7 equals, I already wrote that. You said each factor equal to 0, right? Or you see that 6x plus 7 times 6x plus 7 is 6x plus 7 squared. Square root plus or minus, but what's the square root of 0?
It's not 0.
0. So you still get 6x plus 7 equals 0. Either way you do it, you should get there, and then you get x equals negative minus 7, and then over 6. You can make an x, Jeff. Look at that. Good job. Thank you. Do that for my dissertation defense. Make an x. Very scary.
And that's the answer to that.
Totally. It's crazy. It's crazy. Now watch. Let me just bring some graphical ideas in. Remember that parabola could have two answers. You could have no answers, right? How many answers did we get? One. And how many times did that answer occur? Twice. So there are two answers here, right? So you can have two real. I gotta be careful how I say this. Two real. This is no real, but that means that all the answers would be. If this happens, I have no real answers, right? Here I got two real. I can see them. There they are. There's two real answers. This I have no real answers, so they must be complex. I like that some of you guys are whispering the answer to me. I appreciate that. Right? If it's not real, it must be complex. This one had one answer that was repeated, so that this parabola would look like this. It would sit on negative 7, 6. There it is. It would sit there. It just hits it once. That's why it's got one real answer that's repeated twice. So officially it has two answers. Remember I said the highest degree, the highest power tells you how many answers it must have, right? Well, this counts this twice. It says it's two answers, they just happen to be the same one. Maybe. Cool.
So that one has two real answers, that one has no real answers, that one.
Yeah, this would have two real answers. This would have two complex answers, no real. And this has two real, but they're both the same answer.
Okay. So which has two real, but they're both the same answer?
Yeah, the one that has just one answer, really, but math looks at it as two answers. They just happen to be the same number. Yeah. Math looks at things very strange. All right. Cool. Anything else from homework or? Yeah?
I had one from my math lab. It was one of the latest chapters, all the word problem, but then you had to add, I don't know if it was in the second to last chapter, the one that you gave me homework, like 14.
13.8 is the one with maxes and mins.
It was really confusing, even on my math lab.
It was in chapter 14?
I think so. Might have been.
Chapter 14, they don't really give you word problems, that I would call them. They give you equations, and then you have to plug stuff in.
That's what it was. It was something like that. It was really super confusing.
So, for example, there's one here that says the percentage of smokers who have successfully quit smoking for T months. I like that, so it's sort of a temporary quit, right? I quit smoking. I quit smoking many times. So this is the percentage who quit smoking for T months. So T represents how long they were not smoking, and P is the percentage of those. So if I put 3 in for T, what does that represent?
3 months.
3 months. So I want to see what percentage of people quit smoking for 3 months. And then I put a 3 in, I can figure out what the percentage is. So the question they ask is, actually the question they ask is what I just said. It's kind of fun. Estimate the percent of smokers who are successful in quitting for 1 month, 3 months, and 1 year. So how would I do 1 month?
Times 1.
What would you do?
9.02 times 1.
So it'd be P of 1, because I want to have 1 month, right? And then you just plug a 1 in. You just have to know where your exponent button is on your calculator. Does everybody know where their exponent button is on their calculator? If you have a TI-83, it's this little button over by the arrows.
How about on new calculators?
Oh yeah, on my calculators, it's do you remember? I think it's X to Y or Y is that button. On a scientific calculator, it's most often that.
The calculators you bring have the arrow.
Oh, have the arrow? Okay. Some scientific ones have this. Some have this. The TI stuff definitely has the caret. So I call this the to the button. Right? That's the to the button. So a to the 7th power is big. Right? Whatever the hell it is. Nobody to 7th power is shit. All right. Cool. Anything else from homework?
I thought you were continuing that.
Was I done? No, I mean, that's it. So whatever that is, you throw it in the calculator and you do it. So P for 3 months would be P of 3. So then you do 9.02 times 0.93 to the third. What would it be for 1 year? So you throw this in the calculator, right?
12, excuse me.
12 months. So then you put a 12 in.
Yeah.
So I don't call those word problems, because real word problems, you create your own formula, right?
Yeah, true.
Ted leaves Dallas going south at 48 miles an hour. It's like, Ted, just stay, Ted. There's so much to do in Dallas. Just stay there.
That's also
Yeah,
why I
me
made
too.
it confusing though.
Huh?
It was something like a word problem, but it really wasn't. That's what it was confusing.
There you go. Okay, good. So just be happy it's not really a word problem. They give you the formula. It's really just making sure you can use your calculator correctly.
Yeah.
Yeah.
Got it.
Coolness. Blah, 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 blah. Yeah.
Can we do one problem with the quadratic formula?
Okay. Yes. Because we almost did one here. Did you have a specific one, or you just want one?
Just one.
Okay.
ABC. 3 minus 1 plus 1.
Cool, I like it. So it's just the coefficients of the numbers, right? Be really careful. I mean, if they're evil, if I'm evil, and they give you a problem like this, that's A, that's B, that's C, it's just out of order, right? Just because I move it doesn't suddenly make it become A. That would be crazy. I'm like, I don't like that answer. Let me move that over there. Now it's a whole new answer.
So C would still be 3 on that. It would be 3. And A would be -1 in that.
No. This is A.
Oh,
What's the form? AX squared plus bx plus c. Just because I put that at the end doesn't suddenly make the a become a c.
Wow, okay.
So what's this really mean? This doesn't mean the last number you see is a c. This means the number by itself is c, the number in front of x is b, and the number in front of x squared is a.
Thanks for clarifying that.
Totally. And that's how we solved it, right?
Yeah.
Because the a was there, we divided by it. First step, remember that? And that's b over a is already starting to look like part of the quadratic formula. Right? So if you were here that day, you get to live that experience of seeing the quadratic formula being made. Right? Sort of like sausage being made. So how do I continue here?
X equals negative b.
Negative b, so negative 1, plus or minus. Minus 4. All over 2 times 3. I like it. Cool.
That sound that you made.
It was a neat sound. I like it. It's the end of the semester sound.
It's like a
We're all
zombie
making it at some point. Alright. How do we do
X equals 1.
1 plus or minus. So I get 1 minus.
21.
84.
Negative 4 times 21 is 84.
Good. 1 minus 84 is
83. Negative 83.
negative 83. Oh shit.
Oh, man.
And of course, that's where some of us, we found out immediately after you turned in your quiz that you should put what there?
I.
Yeah. Because you got to take care of that. Square root of negative 1 is I. Square root of 83, I don't know. Can't break 83 up into anything good. So then you stop. Cool. Yes,
You put the I on the right hand side of the column instead of the left hand? That's what that's,
you could, but don't.
okay. That's how my math lab did it, actually.
Well, my math lab has problems. If you do that, it looks like it's under the square root. And can you imagine? I is bad enough, right? I is freaky. Right, you're like they call it imaginary and the whole thing. But can you imagine that? Do you want to imagine that?
Imaginary.
We actually could do this. Let me see if I can freak you guys out. You could solve this. You could totally solve this all day long. Cube root of negative I.
Negative I is
Well, what's I cubed?
1.
It's negative I. So what's the cube root of negative I? I. There you go.
Wait, why is I cubed negative I?
That whole thing we talked about when we first did complex numbers. Right? I is I. We start there. Me be me. I squared do be
Negative 1.
negative 1. I cubed is I squared times I. Negative 1 times I is negative freaking I. And I to the fourth, of course, would be I squared times I squared. Negative 1 is 1. All right, that's that thing we have to know. So if I ask you what's I to the 87th power, you don't sit there and do I times I times I times I times I times. No, don't do that. You should kind of know a shortcut.
About this 3.
Yeah, cool. I to the 87th would be I to the 84th, which is 1, times I cubed, which is negative I. It's crazy. Holy shit. If you're doing your homework, you understand it.
Oh, yeah. Everybody is, man.
Is that really true?
For the most part.
All right. I don't know why they're hiding it from me. All right. I did it. I just don't want him to see it. Yeah, he always marks it up. Damn it. So, I don't know. I come up with reasons on my own head. So anything else before we get back into... We're going to do 14.
We do a problem with the vertex too?
Huh? We did one. There.
We
We
do
did.
it.
Oops. It's too bad. All right. That's the power of coming here on time. Sorry.
That's okay.
Well, how do you find the vertex? Yeah, if I give it to you like this, x equals negative b over 2a. Right, so whatever that is, it's
Plug it in.
so if it was 4x squared minus 8x plus 7 equals 0, the x piece of the vertex would be negative 8 over twice 4. BA, right? You see that?
Yeah.
That's the X piece of the vertex. And then
That would be 1.
you put that 1 back in to get the Y piece.
So that would be 4 minus 8. So
Alright. Yeah.
it'd be 1
Better.
over 3.
I'll just take a picture of this.
Alright. So, real quick review of what we did last time, in case you weren't here last time. I really feel bad for you if you weren't here last time, because I'm not going to go through the whole thing again. But basically, if I have this function, let me see if you were here last time, if you can even answer this question.
So this is 14.2, sir?
This is a review of 14.3.
Alright, so
If I have f of x is 3 to the x, what is its inverse? That was the whole point of the last class. We had to come up with a new symbol. Yeah. What's the base in this problem? What's the base? 3. So it'll be log base 3 of x. That's the inverse. They are inverses of each other. That is why log base 3 of 9 is 2, because 3 squared is 9. It's right. How do inverses act? Whatever one's input is the other one's output, right? The x and y switch. So that's the definition. And of course, the whole point of symbols in math is so that we don't write the question out all the time. My God, if I had to write out, what do you raise 3 to get, holy shit, there's no, the math people would just give up. We can't handle that much writing. Some of us can't write. So you don't want us writing a lot. So we have, that whole question is contained right there. That means, what do I have to raise 3 to make that become this? Right? What do I raise 3 to get 9? 2. So you don't have to write that whole question out every time. I just have the symbol, a shorthand, right? Shortcut way to say it. So we did a whole bunch of them last time, right? And I pointed out some neat stuff, like what's log base 7 of 49? 2. That's crazy. What's log base 49 of 7? Because the square root of 49 is 7. You guess.
What does log stand for?
Oh, okay, I see.
Logarithm. Sorry. Which is like the study of numbers. I can't remember what the hell it was in Latin. We weren't around when they picked a name, so they picked poorly. But we'll get past it. I mean, I really want you to understand. I really desperately. We could have made log base 3. We could have made this the symbol. So if you put a 9 in it, that means the answer is 2. I don't know if you even understand what I'm talking about. Where did this symbol come from? Why does it mean square root? Because somebody wrote it and said that's what it was. What could the square root symbol have been? Any damn thing. It could have been twig. Twig of 9. Right? Why not? We got logs, why not twigs? I desperately want you to understand. Math is a human construct. We made it. Right? So you should know it, because you're humans. We made it, you should know it. You're freaking humans. But you got to understand there was flexibility in it. And once you understand that, you say, oh, well, they chose bad, but okay, I can deal with it. That's just a symbol, like the square root is a symbol. I just got to know what it's asking me. That's all.
You just flip it, kind of.
Do what?
You just flip, kind of.
Yeah, to rewrite it, if I have, so log, what's log base 8 of 2?
So log.
Sorry, 1 second. It's 1/3, because the cube root of 8 is 2, right? So how do I rewrite this? 8? How do I rewrite 8?
Times. No. To the third.
2 to the 1/3 power is
2.
So I can always rewrite a logarithm as an exponential. Right? The same way I can write, if I have cube root of 8 is 2, can't I rewrite that as 8 equals 2 cubed?
yes.
All right, it's the same thing. It's exactly the same thing. It's just that the poor choice of symbol makes it seem harder. That's the only thing that makes logarithms seem difficult to students is the stupid symbol they chose. Right? And I can't hop into a hot tub and go back in time and say, dude, don't freaking make the symbol a log. We're better than that. I can't do that. It's too bad for all of us. Yeah. I just die, actually, for trying to do it.
Didn't you say if the number is smaller, let's say that if it was 1 between 0, isn't it always going to come out negative? Didn't you say that if it was between 1 and 0, like this?
Yeah, if it's less than 1, that's when the power's got to be negative to make it flip. Exactly. I love it. So if you guys picked up on that, if you didn't pick up on that, you can still do the work.
Okay.
But if you did pick up on it, that means you're that much more comfortable with what's going on.
Okay. Makes sense.
I like that. It's my favorite phrase. All right. So that's what we did last time. So today we're going to get into properties of logarithms. Right? And remind me, what are logs? What are logs? The answer to a log will always be a what? Don't tell me number. It will be a... Why was the answer 2 here? Because that is the what?
Power.
That's the power. The logarithm is always a power. Sounds like a good note to take and remember. Yes, ma'am. Sorry.
I just have a question. For example, like if the log is x, and then they give you everything else, how would you just kind of...
So do we again? So log
And then x...
down here's an x?
Yeah, and then 9, and then equals 1/2.
Kick ass. How do I rewrite that in a different form?
X to the 1/2.
X to the 1/2 equals 9. And how do I solve that?
Oh, you just...
What's the opposite of what that is? What does this represent? A 1/2 power is a square root. So if you wanted to, you can even write it like that. How do you undo a square root? What do you do to both sides? Square. So I love it. It started off in log form. Log form sucks because the x is like really stuck down there. So I rewrote it in exponential form and then I can solve it. Is that good? I like it. Okay.
So the answer would be 2 on that, correct?
Say what?
So the final answer on that.
81. Yeah. Because you square both sides to get rid of the square root. Yeah. And let's check it. Log base 81 of 9 is 1/2 because the square root of 81 is 9. You okay?
I can't see because I don't have my glasses, and I don't want to move all the way down, so I'm just squinting.
Oh, okay. Consequences of our choices. You don't want to be close to me. I think I put you over and on this one. I won't take it personal. Spritz, you do it. Splash zone? No? Okay. I had a teacher that was like that, so we had... All right. So, logarithms are power. So here's the really cool thing. If you know the properties of exponents, you know the properties of logarithms. Because logarithms are powers, right? So, for example, remind me, what's b to the 7th times b to the 11th?
B to the 6.
B to the 6.
Listen to you guys. Heard each other. Okay, b to the 18.
Oh my god.
Yeah, me too.
Oh, I'm so sorry.
That was pretty.
I was totally like
That
going
was
off
neat.
that.
That was right.
Yeah.
Don't
Sound
go.
right.
All right.
So there you go.
And what's b to the 11th divided by b to the 7th? B to the 4th. Now notice, so what I was just trying to keep going.
It's like a rhythm.
When the base is the same, and I multiply, what do I do with the powers? Add them. When the base is the same and I divide, subtract. Right? So watch this. Let's see if you guys get this. I'm trying not to do the full proof, because the full proof is just kind of ugly. It really doesn't. Normally I like to do that, because you've lived through it. But this proof kind of gets way technical and ugly. So I'm hoping you guys can get the idea. I try. So if I have log base b of mn, all right, I've gone and made no numbers, Jeff. Why? Why did you do that? So both of these have base b. Do you see that?
Okay.
This is the base for everything involved. So when I multiply things with like bases, what do I do with their powers? Add them. What is the power on the m? Well, it's log base b of m. That's a power, isn't it? That's a power on the m plus, or on the b to make m, plus log base b of n.
Wait, that's divided, or you just wrote a line through log?
I'm sorry. Yeah, I'm sorry.
Oh, okay.
I was making a point. Yeah, that's it. Okay. Cool. So this is awesome. If you understand logs are powers. When I have a log of a product, what do I do when I multiply like bases? I add the powers. Logs are powers. So what do I do if I divide like bases?
Subtract the powers.
That's insane. Subtract that power minus that power, right? So the log of the quotient is the difference between the logs. Let's do it. Let's do a specific example and make sure that we believe this. Let's see if this actually works. What's log base 3 of 9? 2. Now, can't I write this as log base 3 of 3 times 3? Isn't that what that is, right?
Yes.
And if I use the rule, how would I rewrite that? Log base 3 of 3 plus log base 3 of 3. Well, what's log base 3 of 3? 1, because 3 to the first power is 3. So I mean 1 plus 1 is 2. Now, I hope to God you understand that this is not me showing you a good application of this property. Look how long that took when it was just... This is just me proving to you that it actually does work.
Okay.
All right. So let's see an example where the property actually makes sense to use. And I've got a handout with these properties. Right? Ooh, and they're in the book too. So we'll do this handout here in a minute. What did I just say? Shit. I lost my train of thought.
So you were going to do a problem with the numbers.
A real problem.
A real problem. How about that?
Oh, here we go. All right, thank you. You're very nice. Log base, let's see, 8 of, you could do it, Jeff, can you? 3 plus log base 8 of 8/3. All right, can you do log base 8 of 3?
1/3.
Can you do log base 8 of 3?
Oh,
No.
No. Log base 8 of 2 you could, right?
Yes.
Log base 8 of 3? It's gross. It's gross. Can you do log base 8 of 8/3?
Yes.
You could break it up, but let's be smart about it. What am I doing with these two logs? I am adding them. So what's the property say if I go this way? I can put them back together. When do I add powers? When I multiply. So the sum of logs is the log of the product. When I add two logs, I can rewrite that as a single log of the product. Why? Because they're powers. When do I add powers? When I was multiplying. And what happens here?
17/3.
3's cancel. I get log base 8 of 8 is 1.
But isn't that only if the powers are the same?
No. It's only if the bases are the same. And they're both base 8.
Yeah.
Powers can be whatever they want to be, and whatever they are, I add them. Right? So I don't know what that power is, and I don't know what that power is, but I am adding them, which means I must have been multiplying this stuff for that to happen, right?
Yes.
Which is interesting, because then if I saw m to the 7 plus, let me see if you guys don't freak out, m to the 7 plus b, I can write that as m to the 7 times m to the b. That's really all we're doing. So I saw two powers being added. That must mean that these are being multiplied. That's where it came from. Wow, some of you guys look at me like,
No, it's
you're
making
going to
sense.
hurt me.
It makes sense. You're doing. It's not.
All right, damn, I got scared. All right, I'm not going to look at you guys for a
Makes
while.
perfect sense.
Okay?
You did a
Percy?
good job, man. Don't worry about it.
All right. The job I do doesn't necessarily relate to how much somebody wants to kill me.
Another question.
Huh? What's up?
So for the logs, they're like, so you basically add the exponents, right? For like, for the 3 and the 8/3. So can you technically do like, let's say, like 3 is technically 27 over 3, isn't it? Or something like, can you do
Sure.
that and then add the 8 to it and then kind of, reduce it? Or,
No, because you have to multiply them.
okay.
Right? It's not adding these, it's multiplying.
Oh, okay, gotcha.
Yeah. So I add powers when I was multiplying these.
Oh, okay, so it's like the reverse of the law over there, so, okay.
Yeah, so I'm taking, if I have the addition of logs, I can rewrite it as this. Because math, of course, goes both ways. Right? Don't judge. Yeah.
A quick question, just to.
Okay, 1% away.
That number right there. If it was 8/5 instead of 8/3, would that make a huge difference?
Yeah.
So,
Well, sort of. I mean, I don't have to have something I can do anything with. If I have log base 11 of 4 plus log base 11 of doesn't matter, 5, I could write that as log base 11 of 20. Can you do anything with that? No, but you still simplified it, didn't you?
no.
Right? Okay. Not very satisfying, I understand, but I still applied the property. I got one less log. That's awesome. If I want to get rid of logs, normally we do. We're going to simply put stuff together, right? All right, so last and most important property, and this is actually comes off of that very first property. So let me ask you this. What if I had log base b of m to the p? Oh, you just love these letters, I know. Help me out here. Wouldn't this be log base b of m times m times m? How many times? P times. It's not. If it was cubed, it'd be 3 times. I don't mean how many times did I write it so far. I mean, how many times total would I have to write it? I'd have to write it
You don't know.
p times.
You don't
Yeah.
know how much
Whatever p is. And what's the property say? When I'm multiplying, I can make it the sum of the logs, right? So wouldn't this be log base b of m plus log base b of m plus log base b of m? How many times?
P times.
P times. So what's a better way? So there's p of these things, right?
Yeah.
So what's a better way to write that? P times this. So you get plog. Right? If I have x plus x plus x plus x 7 times, that would be 7x. So I have this plus this p times, so it's p times that. And remind me, I want you to realize this is still property of logarithm, property of powers. What do you do with something when you have a power that you raise to another power? What do you do with these?
Multiply.
Multiply them. So that becomes 7 times 2, right? Is that cool? So this is a power, right?
Yeah.
Being raised to a power.
So m times
Its argument is being raised to a power. So then that can come out front, become the multiplication of those powers.
So you wouldn't do m times p though. You would not do that.
Definitely not, because that's not, this is m to the p power, right? All right. So let me give you this handout.
When's the last day you're turning the old quiz corrections? Old quiz corrections, when's the last day to?
Day of the final.
Oh, okay.
If you wait that long, you only get some points if you get all of them right. The later it is, the less points you get.
Alright.
Compared to what you
Can I
would.
give you this one? This is from
Yeah.
the one you just gave back.
Alright, so I got all the rules on there. So I even gave them, so the product rule. Log of the product is the sum of the logs. Quotient rule, the log of the quotient is the difference in the logs. And then the power rule, the one we just did. And that's actually the most useful rule. We'll talk a little bit about what that means. Try those problems that are on the sheet. We work together. You can call me over if you need some help.
Oh, man.
2 and 3 the same.
What's the matter?
Number 2 and number 3 is the same.
What am I looking
Number
at?
2 and 3.
Oh, sure, yeah, sure. Yeah, I guess I forgot to change that last.
That's okay.
So that's a gimme on that one. If you get number 2, you better get number 3 on the first. That's a good.
That was a good one.
That's a good sign that that was not created by some program. That was created by a human. What I meant to put.
Hey, I'm trying to read it by part. just explain. I'm totally lost with this, but I was reading them by parts. And I get it. So this makes that.
Yep. This is where I apply the property. The log of the product. When I multiply, what do I do with the powers? I add the powers. And logs are powers.
So these would be the powers, right?
No. The logs are the powers.
Oh, okay.
Yeah.
But why is it plus 1 right here? I mean 1.
Because what's log base 11 of 11?
Oh, there you go. That's 1.
So simplify what I can.
And that would be the answer?
No. The answer is 1 plus log 11 4.
So this whole thing?
Yep.
Oh, okay. Kind of got it. Alright, let's try it. Let's see what you get first. Oh, okay, so make it. Kind of get it now. I was like, wait, this is 1.
On the example for the sector for the quotient rule, the example that you gave, is it supposed to be 3 minus 11? Or is it the 3 minus 1?
No, it's 3 minus 1. Because what's log base 11 of 11?
Oh, never mind.
Cool.
Thank you.
Sure.
Just to make it clear, so all this is basically what you just went over.
Yeah.
I kind of understand this better. I mean, but
What's up?
I can understand this better now because I'm working through the.
Yeah. Good.
Okay.
I like it.
Alright, thank you.
I estimated more than you were supposed to do. So
Say again?
I estimated more than you were supposed to do the homework.
Oh.
Start.
Yeah, if you do more, I can't complain about that.
Make sure.
Yeah, what's the log base 3? Yeah, just make it 1. You simplify what you can.
75 over
Yeah,
3.
there is the same.
Plus, you can't do any of that, so leave it.
X to
That's the answer.
divide 1. That's essentially
Oh, okay, I was about to subtract some. Just
Well,
write it as log
the
5
quotient
72
becomes
because he said that.
subtraction, but when you divide, you subtract powers.
So-
It should be a minus. Oh, it should be a minus here. You subtract the powers when you divide. So far, but like you said, log base 3 or 3.
I'm telling you, this is the homework.
Yeah, you'll get it back Tuesday, yeah.
Oh, go ahead. Go ahead. He's closer over there. Yeah, like, what if the bases were not the same?
If they're not the same, then you
you can't do
Log base 2 of
anything.
3 is.
They would just stay like that.
Oh.
For the simple form,
Oh.
you know, the base
So I put the one.
And what would be the base here?
Well, how did they do
No,
that?
so here, you just look at the log
Is
base.
this thing?
No, this is log base 11 of 3
Okay.
minus 1.
You find
It's not powers, I think it's log base 11 of 3.
Oh, okay. It's
Oh.
not, I just divided.
Minus
Okay.
1.
But you still
Oh,
need
so
to keep the
that's
base.
not-
Okay.
That's a 1.
Oh, that's a one.
You
Okay.
still need to keep
So
the
they-
base.
Okay. Now it makes
Yeah,
sense.
you do the right thing, but you just,
So now
So
it's
25
reverse.
goes there.
How
and
can
then
you
divide
write
these two?
log
that's
75
So
log 3? You
5
rewrite it as
square.
log.
5 square.
Oh, okay. It make, yeah, 5 squared.
Actually, I
So it would just be minus 1?
It should be 2.
Just like that?
It should be
Well,
2.
no, because log
5
base 2 of 3
5
is
squared
first.
2
Oh, so 1 minus,
5
okay.
square.
equals 2. I mean, equals 25. Sorry. Yeah.
It should be 2.
Yeah, if I haven't given it back to you.
But here, what's your base here? 1?
Alright.
If they didn't show that,
Oh, I do have
It's
to.
always 10.
yeah, always 10.
Oh, okay. So,
Always 10.
so log 10, 1 minus
You don't need to write it.
Never
You don't
mind.
need to write.
the 10?
No.
Oh.
He mentioned the last time that we don't write the 1 10. We know it's 10. Just like the school, the square root, you don't write the 2 here.
Oh,
But you know that
okay.
it's 2.
So you know
So
that.
when you don't
Way too big.
you know
Whatever that number is,
that
it
it's
comes out
10.
front.
So, just like that?
Always gonna be easy, just not the-
So 10
Yeah.
takes 0, the point. This one will be.
Wow. Can I ask why?
So that means 10 is 0.
Oh, okay.
It's 1, right?
Yeah.
Alright, let's take a look.
Yeah. Okay.
Now, real quick, a little side note. It's always good to see these. So if I saw log base 3 of x plus 4, there's not a damn thing I can do with that. Because it doesn't work this way, right? If I had log base 3 of x plus log base 3 of 4, then I could do something. I could make that log base 3 of 4x. That's the direction that the property works in. When I add powers, it becomes the power on the product.
So you can't distribute log?
Totally not, exactly. Same way if I had square root of 4 plus 9, that is not equal to 2 plus 3, right? You see where 2 plus 3 came from? Because you can't distribute the square root. No, it's square root of 13, which is not 5, right? Square root is a symbol that we're more used to. Log is just the same symbol, same kind of symbol, right? So I can't distribute a logarithm through like that, no. Because this does not say log times this, this is log of this. You guys don't like that at all. So it's like, if I write this and somebody said square root times 9, can you see why they might think that? But you know, you go, no, that's not, no, it's the square root of 9, right? So if I see this and somebody says log times 9, you should feel exactly the same way. You should go, no, it's the log of 9, right? Because I love it when I'm like, solve this and people divide by log, and it's like, no. That's like, solve this and they divide by the square root symbol. It makes just as much sense. Well, x is 1 divided by a square root symbol, Jeff. Oh, okay, all right. No, I don't want to make you feel that. That's the kind of way you need to look at the log. We're not used to it, but it's just like a square root symbol. Same idea. It's just a symbol. That means a certain question, right? Represents a question. So what's the property I can use here? Since I do have a log of a product, I can write that as log 3 of 3.
Plus log 3 base. Equals 1 plus 1.
Good.
That's a fun answer.
That feels a lot like if I said simplify square root of 50, what would you do?
25 times 2.
Yeah, it'd be square root of 25 times square root of 2.
5 and 2.
You do the part you can, and you leave the part you can't. It's exactly what we just did. We did the part we could, we left the part we couldn't.
Yes. That
That sounds like a good idea. If you can't do it, you probably should leave it. That's all you can do. I like it. Alright. I like it. Alright. And then the second and the third problem. Put them together. We'll make it problem number 5. 2 plus 3. So log 12 of 3 plus log 12 of 4. I must have liked that problem a lot.
3 times 4.
And that's the reverse of this, right? Of course, again, that's just math going both ways. So log base 12 of
3 times 4.
12 is 1.
Yeah.
Kick ass.
For both answers.
What's up?
Both answers.
Yeah, and then number, yeah, exactly. It's a little different. No, I'm joking. All right. And this is a lot like square root of, you could do it like square root of 3 times square root of 3. Can I do either one of those?
No.
No, but when I multiply them together, I can.
Yeah.
Right? So that's sort of like this. Logarithms are sort of like radicals. They aren't the same, or else why the hell would we come up with them? They must be something different, but they are a lot like radicals. You can see a lot of similarities. Woo! All right, let's see. What about the quotient rule? Number 1.
Log 3 to 3 minus log 3 to 3.
Yeah, so I got log of a quotient, so I can write that as the difference of the logs. And then, which part can I do?
1 minus log.
Yeah, that's 1. And that's, I don't know, 1 point something. Whatever it is. You guys with me? I mean, what would this be between? What two numbers would this be between? The answer to this.
3 and 6. Oh.
What are you thinking about? What do I raise 3 to get 5? I don't know. But what do I raise 3 to get 3?
1.
What do I raise 3 to get 9?
2.
So the answer to this must be between.
1 and 2.
There you go. See? Yeah.
Just the way that it's done, the example is done differently. I'm wondering, is the answer still the same if you do the log base 3, 1 minus 5? Because like on this one it says log base 11, 3 minus 1. When you do log 11, or log base 11, 3 minus log base 1.
Yes, because on this one, I could do this one. I just do whichever one I can do. So on the example, it's log base 11 of 3 over 11 equals log base 11 of 3 minus log base 11 of 11, right?
Right?
Which one of those can I do?
So log base 11 of 11.
Yeah. So that's why it's
So it's
written
still the same. It's just
second. I just did the part that I could. That's all. You do the part you can, wherever it is, and you leave the part you can, wherever it is. So what about number 2?
Log base 8 over 75.
Yeah, this would be log base 5, and this is just the reverse. And of course that becomes, which becomes 2.
5 squared, 2.
2, right? Is that cool? Because what do you have to raise 5 to get 25? To the second power. So are you cool with that?
Yeah.
Alright, good, because that's the difference. I can make it the quotient. And then 75 divided by 3
It's 25.
is 25. 3/4 makes 75 cents, right? And then log base 5 of 25 is 2, because it takes 2 5s to multiply with 25. Alright. Totally.
I mean-
Dude, that was...
I didn't say that.
You passed a few words on your way up. That was good. that was a lower level reaction required to that one. That's all right. These things happen. All right. I don't know if you guys remember this. Is there a base on there?
10.
Good. It's understood to be 10. That was an awesome response. So if there's nothing there, there really is something there. Just like there's nothing there, but yes, there is. There's a 2 there. We know it. It's just invisible. So how can I rewrite this? There's 2 ways to do this. And I kind of want you to use a property.
Log 10.
Log 1 minus log 10. And what's log 1?
0.
Good. 10 to the 0 is 1. And what's log 10?
1.
So you get negative 1. And of course, if you just do it directly, what do you raise 10 to? You get 1/10. You would raise it to the... How do you flip 10 and make it 1/10? What power? What's log base 3 of 1/3?
-1.
-1. Kick ass. So what's log base 10 of 1/10? -1. So I didn't need the property, but I just want to show you the property gives us the same answer. It's freaking better, or else we got to throw the damn thing out. Thankfully, we don't have to throw the damn thing out. It worked. Okay, maybe.
It's a little confusing, but it makes sense.
Much like what you just said.
Log 1 is 0. Or-
Totally, yeah. Log base anything of 1 is 0 because anything to the 0 power is 1. And of course, not 0, not all. You with me?
Yeah.
All right. You can't have a base of 0 on a log anyway, so it's all good. So that's just a fact. So if I said, what's log base square root of pi of 1 is 0, right? And people stop there. I'm like, come on, keep going. Look at it. It's an easy answer. All right. So let's finish this up here. The last 3. So let's see, if I have log base 3 of a squared, I can rewrite that as 2 log 3a. I like that. So this is the easiest property to use. Now be careful. How do you have to approach this? Why was this one easy? Because I can see the power.
Next to the 1/2.
Beautiful. You got to rewrite this as a power so I can see what the hell's going to happen and what happens.
1/2 log.
1/2 comes down. That's the property. And then finally, this one, log base w, e to the square root of r. Looks disgusting, but what happens? The power comes down. Square root of r log base w of e. So all that happens is that power came out front. That's it. So let's verify that works. What's log base 10 of 1,000?
10. Okay. 10 goes into 1,000 sometimes. Oh, it's not. I'm sure. I'm sorry, man. Just keep going.
So this is not division, right?
4.
How many 10s do I need to make 1,000 if I multiply it? 3, right? 2 of them makes 100. 3 of them makes 1,000. And the quick way to see that is there's 1, 2, 3 zeros. Right? So the answer to this would be 3. So, but how can I rewrite 1,000 then? It's 10 cubed, right? Stay with me now. And then using the property we just talked about, I can bring that 3 down, right? And what's log base 10 of 10? 1 times 3? I get the same answer both ways, right? And again, this is just a demonstration. Anytime I show you that, I prove to you that it works. I would never do it that way if I had to do it. I would just do it directly. But this is just to show, hey, I get the same answer if I do it with the property. Let's see. So you probably want the practice test. I would suggest.
It's on Tuesday or Thursday?
Thursday. What do you think? What's got to happen before we take a test? We got to have a day that we review. So Tuesday is going to be a review day. I'll have the answer key for this, and then Thursday is the test day.
Wait, that's the final, right?
No, the
Oh,
final.
no, wait, that's for this chapter, yeah. Sorry.
Finals.
Finals on the 28th.
It's coming, but it's still a little ways off. I can't remember. I put it on the homework sheet. 28th?
28.
My little brother's birthday.
God, man.
Someone else celebrating. We're all taking the test, and I'll review too.
2 more weeks, and then
Yeah, 2 more weeks.
No.
Wait, are we in this class? I mean, this semester, we're gonna go over tan and all that? Or?
Oh, hell no.
No, okay, I was like, wait up.
Trigonometry is 170
Oh,
or
it's 'cause in high
176.
school. High school had a class for that? Oh my god, it was just
Oh, yeah, and like a class on its own.
yeah.
I stepped out.
Do you teach 160?
Oh, yeah. I love 160. I teach it every semester.
Yeah, I need to take it for my major. But
I'm teaching 120 and that's in the fall.
Yeah, but I'm taking over the summer.
would
I miss 120. I used to love teaching all the
would
time.
this class get you into 160?
Sort of.